Thanks for the challenge. Here's the response.
All right, 2004 Land Cruiser 100. And this car has a very unusual problem. The ABS light and the brake light remain on all the time. And the owner said that when he scans the system, there are no codes that are showing up. Originally, when he told me that, I thought, this is maybe an aftermarket scan tool issue, but he told me he has a tech stream. So this guy happens to be a very keen vehicle owner. He knows about wiring diagrams. He knows about good diagnostics. So this is a wonderful client to have. Keeps me on my toes. And he has taken care of this car very, very well. Look at this. Beautiful. So the Land Cruiser 100, this car was fully decked out with so much electronics, and a lot of people used to have issues because the electronics were quite advanced for their time. This is 2004, but it had multiplexing systems here and all the weird computer electronics in the car. And what happens is, typical with these cars, if a system goes wrong, people just disable that system. Well, he's having none of that. He said that there was some wiring that was done to the car, and he took out a few bulbs that are put on the cluster, and there was some tape in the cluster. So he took out the bulbs, went to a wiring guy, and they restored the wiring back to factory. But now he has this issue. So let's get the key. Put the key on. So you can see that the brake light is on, and ABS light has just come on. So let's hit the brake and put the handbrake down. Handbrake is down. Brake light is still on. ABS light is on. Now, I noticed that when you put on, the ABS light doesn't come on immediately. So let's see that again. Yeah, so it's off right now. Then it comes on. Okay, so apparently no codes. Let's scan the system. My tech stream is fired up on the computer right there. So let's scan the system and see what we have in terms of codes. And if we don't have codes, I'm going to pull up the wiring diagram and see how to proceed with this problem. We're in tech stream, just finished scanning the car, and what do you know? No codes in the system. So this is the ABS. The key is on. Let's get in here. And there are no codes. Interesting. So let's go to the data list real quick. Okay, pretty thinned out data. Nothing much to see here. Got the wheel speed, deceleration. Now this is curious. ECU IG power voltage. It says here too low. We'll test that. Everything is off. Number of DTC is 0. So the computer is not complaining about anything else. This one is the only thing that I'm seeing is weird. But since we have no direction on the data and on the codes, let's pull up our wiring diagram and see where to proceed with this car. All right, we're in the wiring diagram. Now, a quick word. The owner of this vehicle said that they tried to troubleshoot with a shop and they had the wiring diagrams and nothing seemed to match. Well, most likely you're using Euro diagrams. If you look for right-hand drive, Land Cruiser 60, 70, 80, 90, and 100 series online, most likely you will get Euro diagrams and they will not match the JDM vehicles. This is the publication you're fixing to get if you want to work on the Land Cruiser 100 series with wiring diagrams. And you can't download this anywhere. Prove me wrong. Try and see. Nobody has this online. You need to buy it. So the JDM Land Cruiser 100 and the Euro do not match on the wiring diagram. They don't even come close. They are from two separate factories and they do their own thing. The exterior of the vehicle may look the same, but the wiring diagrams will not match. Okay, so be careful over there. And these diagrams will be in Japanese, as you can see. So you will have to do some translation when you're using. All right, so let's go to the ABS. This car does not have VSC, so let's go here. And let's look for our lights. So this is the ABS and brake light. They're in the combination meter and they're fed by the 7.5 amp meter fuse. And from what I'm seeing here, they're not related. So the ABS lamp, and it's an LED, is controlled out of Y12, and it goes through the cowl side junction block, and it is controlled by the ABS computer on connector C pin 8. It does have another split over here. Let's see where it goes. Goes around, comes through the diagnosis connector, that's under the hood, and goes to the ABS solenoid relay, where it is connected to ground. So what this circuit is to illuminate the light when the ABS solenoid relay fails to turn on. So you see, this is the off position. When it's in the off position, this will connect to ground and it should turn on that light because it will ground this line. When it's on, this will not light up, and that diode prevents the voltage from kicking back on this line. So right now we know that to command this light on, we need to ground this line, Y12. Let's look at the brake light, fed by the same fuse, and it has a split point here. One comes out of Z18 and the other comes out of Z20. Let's chase Z18. It goes through the cowl side junction block and it goes to the parking brake switch. So this is on your handbrake switch. When you pull the handbrake up, it'll close the switch and the light should illuminate. Again, we are grounding it. When you put the handbrake down, you open the switch and that should be open. Now, this other side branches off, and one goes to the BRL on the ABS computer. The other one comes to the brake level warning switch. So this is the warning switch inside your master cylinder. This switch will come on when you lose hydraulic fluid. Then the other one here, if you have a vacuum brake type system, which we do not, we have the hydraulic, but if you have the vacuum brake, which when you have a brake booster, when you lose vacuum in the booster, this turns on and it illuminates that light. And why do you need a warning? Because when you lose fluid and when you lose vacuum, you also will lose your power braking. Now, what is this for? This should just report that you have either a warning level switch on or a vacuum switch on. So that's just to report to the ABS computer. And I figure you will report this because you need to turn on the buzzer, okay, to warn the driver that you have lost brakes. So right now, I'm not seeing how these two tie in together. There is no way you can have a command that will turn on both the ABS and the brake at the same time. So either somebody has tied these two together and has tampered with the cluster. Oh, no, that's not the case. I've just remembered, when you key on, the ABS light remains off and then comes on after about 3 or 4 seconds. So we have two separate problems here for sure. So let's start with ABS and then we'll go to the brake. So let's go to the ABS computer. I want to probe this line right at connector C pin 8. I want to interrogate what the brake computer, the ABS computer is doing. So let's look for a component location here. It should be in the instrument panel. Yeah, and here it is. ABS computer with or without VSC, you have it in the same location. And the location is above the knee panel. If you remove that and above the switch panel, you should have this, and it is just above the tilt and telescopic computer. So we may need to remove the tilt computer and then drop this down. Right, let's go to that location. Okay, we are probed on the ABS warning lamp control line, and on this line we should see a ground to turn on the light, and then when it's off we should see some voltage coming from that instrument panel. So it should come through the fuse, through the diode, through a resistor. So we should see a bit of a drop in voltage, but this side should end up having close to between 10 volts, I think, or slightly less when it is off. When it's on, we should have a ground here. Okay, so we take the key, let's put it on. And what? That is interesting. Look at that. Let's put it off again. Put it on again. And we have a ground at first, and then it goes off. So this is functioning as it should. So what does that mean? Is our ABS lamp connected to something else? Well, let's see. Let me take a test light connected to battery negative, so it's to ground, and I want to just touch it over here, and I want to see what my ABS lamp will do. Alright, I have my test light here. I've connected it to battery negative. Let's test our test light, make sure it functions, and there you see. So right now I'm holding a ground on my tip, and what I want to do is come here and ground this while the key is on. So let's put the key on. Right, so there the ABS light is on, and according to my scope that ABS light should be off right now. So here's my ground. Let's touch it here, and look at that. We're turning off and we're turning on. Off, on. Okay, so we are on the right control wire, but the cluster is doing the opposite of what it's meant to do. Why is it turning off when it's supposed to be on and on when it's supposed to be off? This means that there's nothing wrong with my ABS system. The problem is this circuit is behaving opposite of what it is. So that's something funky. I think somebody has either rewired the cluster, or definitely has rewired the cluster, because there's something is going on in there. I think that diode has been either reversed or something has been done in the cluster to do this. But if the diode was reversed, I wouldn't be seeing what I'm seeing here right now. I'm seeing 8 volts. I shouldn't be seeing that voltage if the diode is reversed. That diode would block the voltage coming from the fuse. Somebody has done something funky in here. So the diagnosis for this one is pretty much done. This wiring needs to be corrected. So let's move now to the brake warning switch. So I want to prove that this ABS light is doing opposite of what it's supposed to do. So what I've done is I have pulled up my trouble code screen on the text stream, and we're going to cause a trouble code. So I want to go to the hood, and I'm going to pop that ABS solenoid relay. That should surely populate trouble codes, and our ABS warning light should come on, in our case it'll actually go off. All right. So we've left the probe there, and we will just go to the relay box. Okay, so our ABS solenoid relay is this one here, okay, which is the second one, 2, this green one. So let me pull this, and this should cause trouble codes. Okay, let's go back and see what happens. And we've got open or short circuit in the ABS solenoid, and our light is off, which is actually on. So confirmed, this system is working correctly, but it's working opposite. The driver information system is not reporting correctly. All right, for our brake warning, I want to first interrogate this line and I want to see whether the parking brake level switch is keeping that light on. All right. So, lucky for me, right here, we have that T off from this line. So we're going to come on A3 and probe that yellow-green wire. So right here at the computer, that's what we've done. So that line is probed. Now let's see what we have on that line, and I'll focus you also on the instrument cluster. Okay, now we are on that line and I have my test light again. This time, my test light is connected to battery positive. So let's test our test light, and we have a good connection there. So right now I have a positive voltage on my tip, 12 volts there. And on our scope, we can see that we are having some sort of a ground, but it's pulsing. So is this really a ground or not? How I will know is if I touch this with the test light and it brings it up, then it's not a ground, okay? So there we go, touch with the test light, and I can bring up that line and it is not lighting my test light. So that tells me this is not controlling my bulb, okay? That bulb is still on and it doesn't matter what we do over there. But then, do I have this connected to my parking brake? Okay, right now the parking brake is up. There should be a ground here, and there is no activity. Let's put the parking brake down. The car will move a bit. Okay, so the parking brake now is down, and we still have the same thing on our scope. Let's take our test light and we check here, and we have exactly the same result. So what do we know? We know that the switch in the master cylinder is not on, and it is not the one that's keeping that lamp off. However, is my parking brake switch working, or is it stuck on? All right, we have seen that we do not have any activity over here. So our level warning switch is not an issue. We do not have a vacuum warning because we do not have the vacuum system. We have the hydraulic. So now let's come and interrogate this side for the parking brake. So the parking brake, we can either go to the parking brake itself, but that means we need to tear off the center console. That's quite some task, and I don't want to do that only to find that we are good on that switch. So why don't we come here to the cowl side junction box, and we are going to come here to this connector, Kamegi K, pin 13. We're going to go to Kamegi K, pin 13, and then see if our red-white receives a ground from the parking brake switch when we actuate the parking brake. All right? So where is this? Let's come to the junction block. That's the cowl side junction block. Right hand, and we're looking for Kamegi K. There it is, and we are supposed to be on pin 13 is right here. Okay, let's probe that, and then we are going to actuate our parking brake, see whether we have ground at this point. All right, there is Kamegi K, and we are in pin 13. Let's go to the scope and see what we have there and actuate the brake and see what we'll get. Okay, our Pico is running and there's a pulsation that's going on that. I don't know what that is. Let's put a brake down. And this switch is working. Up, down, up. So there's nothing wrong with our parking brake switch. There was no need of punching out that center console. See how much time this would have taken me. Now we know that this light on the dash isn't being actuated by anything, because whether this is down or up, that light remains steady. Okay, so let us now give the owner the news he has to repair his wiring. This seems to be all a wiring problem, and then we are going to proceed. But we are done with the diagnostic. So our brake switch, our brake lamp warning is not connected to the right thing, and then our ABS warning is doing opposite of what it's meant to do. All right, let's talk to him, and then if he approves, let's do the repairs. So in the course of this diagnosis, the owner of the vehicle was starting to get a bit anxious, and he tried to help out by consulting Gemini. And this is what he sent me. So we're going to read what Gemini said, and then we're going to analyze Gemini's finding at the end of this diagnosis. I think this must have happened when removing the AHC. Now, the AHC is the active height computer, which was removed from this car. That is the active shock absorber system, which is electrical. And Gemini says, how the height controlled removal broke your radio and ABS. Instead of disconnecting the AHC computer properly under the dash, the mechanic took a shortcut directly behind the cluster. 1. They cut wires on the cluster plug to kill the height control lights. 2. When they did that, they accidentally cut a shared master ground or ignition power track that the ABS system and the cluster gauges rely on. 3. Because that ground circuit was severed, the cluster began backfeeding electricity through the radio's accessory line to find a path out, which is why your radio turns on when you pull the handbrake. 4. To hide the fact that the ABS light came on as a side effect of this bad wiring, they cut the ABS wire and rigged up that reverse logic cheat bulb. And he says, I have given Gemini AI my scenario, and that's what it has answered me. So Gemini AI is fixing to take my diagnostic job, eh? Well, we'll see after this. So why don't we just finish the diagnosis and repair, and then we are going to analyze what Gemini has written. All right, let's proceed with these repairs. So what we're going to do is remove that instrument cluster, and we're going to need to map these connectors. Now, one thing about Toyota, for the longest time, as far as I can remember, they always use the same color of wires on all their instrument cluster lines. So these sky blue lines. If you do not have service information, you are going to be frustrated trying to find lines on instrument clusters. You'll just see a bunch of wire colors that are all sky blue, all the same color, and don't waste your time. Get proper service information. So we have it mapped out in the service side of the manual, and this is the instrument cluster. We've got connector A, B, C, and D, and to know what they are, we've got a handy dandy diagram up here. We are looking for our ABS line, which is here, A19. So A is here, 19 is down here. Now you've got to realize that we are looking at this instrument cluster reversed. This is the cluster looking at you, and these are the connectors of the cluster. So you have to map it in your head and reverse it when you look at the wiring in the car. So this one, when you turn this cluster around, this comes all the way to this side, and then this outer becomes the inner. So lower on the inner side will get 19. Let's go to the car. All right, instrument cluster is removed, And this is our connector. This is the line, and we have probed it. Okay, so that's line 19. So I've pinned into it, and I've put it on channel 2 on my Pico. Channel 1 is still down here at the ABS unit. So this is the control line for the bulb, and it should terminate here. So that's what we want to test. Now, we won't be able to test anything now because this is a naked line. We need to act as a bulb. So let's bring our test light in. Here's our test light. We are connected to battery positive. Let's just test our test light, and there we go. So what we're going to do is probe it in here. Now, what do I expect when I see it in here? Remember, on our wiring diagram, we have this line currently connected to ground through the ABS solenoid relay. Okay, so I should be able to see my test light light up here, and I should see it on my scope as well. There we go. So we have a nice bright test light, and on the scope we have the red and the blue. Now, if you look at that red, you see the red is slightly elevated versus the blue. I've put them on the same zero plane, so that blue has a lower ground than the red. Well, obviously because this is a long length of wire coming up until here, so our ground will be elevated here. Basically, this is a voltage drop that we have between the ABS unit and this because of the extra wiring coming through the instrument cluster. But I'm interested now in what I'm going to see. So let me look for my key. All right, got the key. Let's put it in the ignition. And when I turn this on, this light should remain on a bit, then go off. So it's on, then off. And we can see on the scope, both the blue and red are high. Let's turn off. Back grounded. Why? Because that solenoid relay is grounding that line. Let's do that again. On. And it turns off. So what we have established is the wiring integrity of my vehicle is good. There's nothing I'm doing here. The problem I have is in the cluster. So we're going to address that later. Now, I'm interested to find out what's happening with the brake line. So let's go and map out our brake line. Okay, for our brake line, we need to test both Z18 and Z20. Let's start with Z20. We have the brake level warning switch. We've already established that the brake level warning switch is not on. So what we're going to do is to come here to the ABS computer, put channel A on A3, and then on channel B, we are going to come here to Z20, and we're going to probe channel B here and do the same thing, put our test light in it. And then what I want to see is if I have my test light signal coming from here, going all the way to my BRL line here. So that will tell me the integrity of this line here. Go to our service information. This is an inverting circuit. If we have VSC, we don't have VSC, so we have branched off like this, and we are coming here on C11. Let's come down. C is this one, 11 is right at the top. Very easy to get to and to map. So again, remember, this is inverted. So when we turn around, this comes all the way here. So it is actually going to be this pin over here. Back at the ABS computer, I have probed the sense line for the brake level switch, and it comes all the way to that pin, which is that. Now, there's some funky stuff going on here, but this is not our wire of interest. Our wire of interest is the one I have probed. When I'm going to put a key on, all I'll do is to insert my test light in here connected to battery positive, and I want to see that that line comes all the way from here down to the computer. Or I can even do it at the computer over there. Actually, let's do it at the computer. So we see in the picoscope both the red and blue on the same plane. Let's first check our test light, and it's working. So right now I have 12 volts at the tip. Let me touch that. It should not light, and it doesn't light. And we see clearly we have both channels going high. So that line is continuous, nothing wrong with it. Now let's look for the parking brake switch line. All right, for our parking brake, we know that we have continuity from the switch to the junction block, because when we were at this pin, we got that signal. Now, what I want to do is to come here and isolate my line on pin 18. Let's go to our map here, and we are looking for the parking brake switch C13. Okay, now let's go down here and wait a minute. There's something here that is interesting. Let's go back to the wiring diagram right quick. Now if you look here, we are on pin 20 for the brake level warning switch, but we're on pin 19 on the map. What's up with that? Are they labeling these differently here? So it can't be labeled different, because yeah, there's something wrong with my wiring diagram here. So these, I didn't even notice that. These aren't correct. Let's see. When we're here on the ABS, it was pin 12, but on the other side our ABS was pin 19. So this is a wrong designation. Very good to know. I'm going to correct this in my TIS, because these pins are not correct. Let's use the map that we have in the service manual. So parking brake switch, and it is C13. Let's come down here. C13 is 1, 2, 3 from the top, and is this one here. Again, when we flip this over, it's going to come here, and that 13 is going to be down this side. Okay, the third one down. Let's go for it. All right, I am in that line, and this is the one that something funky has been done to it. Look at that. So I don't like this, but we test. We don't go by looks. So I'm going to put my test light on this other side, and then we're going to actuate the parking brake and see if our signal is reaching all the way there. So here's my test light. Right now the parking brake is up, and we are grounding that line. Let me come here to the parking brake and put it down, and look what happens. It goes off. So bring it up, down, up, down. So this line actually has got good integrity up to here. Does that mean my cluster is messed up again inside? It sure looks like that, but this feels very strange in this region. So let me move my probe from here to this side, and I just want to make sure that I have a continuous line on this other side. All right, we are probed on this other side of that line. Our test light is in place, connected to battery, positive. So let's come here, lift our parking brake, and what do you see? Test light comes on, parking brake down, off, on, off. So we are done with the wiring of the car. Nothing is wrong with the wiring of the car. The parking brake warning and the ABS warning are intact on the car side. So someone done messed up that cluster. Maybe it was Aaron. You then messed up Aaron. That cluster has an issue. So let's go and open that cluster, and we're going to pull the motherboard out and fix it, because that's where all our problems are. Right, lastly, before we go to the instrument cluster, let's just verify that we have power on this line from the 7.5 amp meter fuse that comes to this location here. Since I don't trust that, let's go to our service info and let's look for it here. So the ones that power the brake line is this one. They've been calling it a different thing. Charge positive. I don't care about that. I care about the pin A1. A1. Very easy location. So when you turn this, A comes on this side, and then 1 will be right at the top here. Okay, so we have that already pinned. So our A1 is there, which is this one here. It looks intact. Nobody has tampered with it. We've put our red channel on the Pico there. Let us go to the Pico scope, fire it up. It's ready, and let's turn the key on, and looks like we have a power feed there. Now, is that power feed enough to sustain the meter? Let's connect our test light to this ground location here, and we're going to take our test light and probe that line, and yes, it is. So that is a hot feed. It is able to sustain a load. So we are done with the car. Let's go to the cluster. All right, here's the cluster on the bench. Now, one thing people do not like is the way I talk about my fellow mechanics in this country. People think I'm too harsh for nothing. I tell you guys, I know my kind. Look at this. This is the ABS LED. Somebody has scratched this off over here. Okay, that's why this is not working right. Let's come to this other side and look at the brake LED. Same thing has been done here. There are two groups of people that you need to be very afraid of as a car owner in this country. One is electricians. Those guys are called kawaias here. Those guys are butchers. This is the kind of garbage that they do to people's cars. I don't know why this was done, but if they wanted to disable that light, why couldn't they just tape over it with electrical tape and leave it alone? Now they have damaged the board. I hope this is not a multi-layer board, because that scratch looks like it's quite deep. I'm going to look at it under the microscope in a moment and see what's up. The second group of people are programmers. Those guys are so bad, they will brick your car and they will turn off their phones and refuse to contact you. You need to be careful who repairs your vehicles. Let's put this under a microscope. We're going to start with the ABS circuit here. So I'm going to remove the LED. Then I'll see the damage that has been done on the board. Then we're going to restore it, and hopefully this should work. But this is why I tell you, here in my country, things are not good in this industry. All right, that's how it looks like under the microscope. So there's a deep gouge over here, and this doesn't look like a multi-layer board, which is a good thing. So what we're going to do is remove the LED. Now, LEDs, you can't use a heat gun because you'll melt them. So we're going to take two soldering irons and put one on this side, one on this side. Low temperature, around 350 degrees. And let's remove it because I need to preserve that LED. I do not have another replacement. I need to order some of these because this damage is something I see often, and these LEDs also die. So let's just quickly remove it. Yeah, there we go. Nice. And that gives us a cleaner view of what's happening there. So let's clean that up. All right, so this pad has been severed. Now, I'm not sure whether we're supposed to connect it on this side or on this side. No, but it's the same pad. So we'll just connect it all the way from here to here. And this should be good because this whole pad here is supposed to be one. I don't know if you have a connection here. So we're going to make sure that this is connected nicely. Let's compare with another pad here that didn't have an LED. See how it looks like. That's that one. Now this board is not just a regular board. There's some logic here such that when you disconnect the computer, the ABS computer, this light is supposed to remain on. So this board has its own logic. So that's why it's behaving the way it's behaving. It loops the ground to a different controller. So you just can't disconnect the ABS computer, for example, and then just leave this LED here because it will turn on even without the computer in place. If you want to remove something like the active height control, which is what they were removing, what I suggest is you completely lift the LED from the board. You desolder the LEDs. Don't do stuff like this. This is very stupid to do. You're just damaging the board for no reason. Let's use this service manual to our advantage in order to fix these LEDs properly. So here at the ABS line, we have pin 19. On pin 19, we're looking for a diode, because we don't have VSC, we're looking for a diode that's connected to pin 19 on the negative side of the diode. And then we chase the positive side of the diode and look for a resistor that's connected here. And on that resistor, the other side, we're going to connect it to our LED for the ABS. Same with the brake. We're looking for these two diodes, which will be in line with C11 and C13, which is the brake and the parking brake switch commands. And then at the back of these two diodes, we are looking for a resistor that's connected there. And then the other side of the resistor should connect to our LEDs. Okay, this is the brake LED. I have traced where this line is supposed to go, and it's supposed to come here to that test point. It's actually supposed to connect to this, so that's where it has been cut. So let's take a wire and connect from here all the way to this point. Then we clean up. All right, so that's done for the brake. That should restore that. Now the ABS. So which side of this resistor is supposed to be connected to the LED? Let's start from this side and let's go to pin 19 here, and that's continuous. So this is the power side of that LED, which means the LED is meant to be connected on this side. Now if you look on that side, you will also see that it goes to this. So this is that transistor which is meant to turn it on also if you disconnect the ECU. However, there is no via to go to the other side of the board, which means it goes to the other side of the board via layers, of which now we have severed those layers when that guy scratched. So this is actually a multi-layer board. So what we're going to do is to take a wire, connect it this side, and then go to the other side of the board and connect it to our controlling LED. That should fix the ABS LED. All right, that's a fix. All right, before I put this cluster back together, I just want to make sure that this circuit is working. Let's put the key on. It's not working correctly. Let's start with the ABS. You can see the ABS is still on. Now it's on permanently. It's not going off and then coming on. That's curious. And now the brake is still on. Let me actuate the handbrake. Up, down, up, down. So nothing has changed here. And on this side is now solid. So something else is up here. But there's something that's bothering me. Why do we have a missing diode on our PCB? That diode is supposed to be there. Let me go back to my desk and think about this, but yeah, something is up. Okay guys, I think I figured out what was going on here and why all this was done. Remember when we were here on this circuit, I said I don't like the fact that we are missing a diode in this location. So let's go to that location, and it is right over here. We're supposed to have a diode here. We're missing a diode here. And how do I know that? Well, let's go to the service manual. If you look at this schematic, you'll see that we don't have VSC. We're supposed to have a diode between the command line and that resistor. Okay, we didn't have it here. And I also did not see one on this side. Instead, we are seeing this thing. Okay, so let's come back here to the microscope. Move our board here. That is a transistor. So this transistor is present, diode is absent, and according to our service information, we are meant to have a diode if our vehicle is without VSC, but we're supposed to have the transistor if our vehicle is with VSC. So guys, what happened here is someone changed this cluster with a cluster for a vehicle that is supposed to have VSC. So when they put it in, they saw what I'm seeing right now, because I've restored this circuit exactly how it was to factory. I've restored this line and I've restored this line. So what happens when you bolt in a cluster that is for a car without VSC, your cluster will not read the VSC, and guess what? Those two transistors are going to permanently turn on the brake and the ABS and the VSC light. Now, this VSC light is not turning on because somebody has tampered with the VSC light over here. But the ABS light is on permanently and the brake light is on permanently. Then what they did is they saw, we need to cut the line that is the control line. So they tested and saw that we have got 12 volts coming on one side of the LEDs. Then they severed the control line of the other side of the LED, but the brake light remained on. The ABS light went off, but that's because they simply were severing the line from the transistor to the ABS. Okay? To repair this cluster, we need to remove this transistor. Then we need to locate the transistor that's on the brake line side and also remove it. When we do that, this vehicle now will function as it's meant to do. I tell you, respect your part numbers. This is what I keep telling people. Just because you've got the same connectors and you've got the same bulbs inside does not mean you can just bolt in two different part numbers. The reason why you have two different part numbers is because one cluster is supposed to be with VSC, one without VSC. Now, we will not have the diode. That diode is simply an input protection diode. In case you send 12 volts in, it's supposed to protect the LED or the board. We won't have that protection. So if there's a short circuit that happens with this cluster, it's going to fry everything. Unfortunately, there's nothing I can do about that because I do not have any diodes with me, and I don't even know the type of diodes that are supposed to be used here. But let's remove that transistor, and then we proceed with the testing in the car, but I think this will fix our problem. Set my heat gun to 380 degrees centigrade, and I put Kapton tape. Don't want to damage my connectors there. Let's go for it. That was easy to remove. Okay. And now, I don't even need to clean that. Before we look for the other one, why don't you go back to the car and see now if our ABS circuit is going to work as intended. All right, back in the car. Let's see if this will work now. Let's put the key on. Yes, now it's working. Okay, that's the ABS lamp. Put off, put on, should initialize, and then go off. Nice, good. Now let's do the same for the brake light. Let's remove that transistor, and this work should be done. All right, final transistor removed. That's this location for the brake warning switch. Then, since there's a diode missing, we need to bridge this line. Otherwise, we'll not get the brake warning from the brake switch. Right, that's done. Let's go to the car. Okay, our cluster is back in position. So when we put the key on, the ABS computer should initialize the system, and the ABS warning should come on, then off, because it checks the electrics, and then the brake warning here should come on, then off to check the hydraulics. My handbrake is down, so this should initialize on and off. So let's key on. And beautiful. So you saw the initialization on both of those. Let's do that again. That's key off, key on. Nice. And then now, when we put the handbrake up, we should get the warning, and down should release. Up, down. Okay? We start the car. Make sure everything else is good. And it is. So I'll calibrate the needles and put them back because that has its own special procedure. But this is done. Now you may wonder, what about the hydraulic warning when you lose fluid in the master cylinder? Well, let's test that. So in order to see that, the handbrake needs to be down. Let me open the door briefly. So I'll take my test lights. My test light is connected to ground right here on this stud right there. And let's come to the ABS computer. And this one is the level warning that comes from the top and it terminates here. So if this line has good integrity, if I ground it, I should be able to light my bulb. So I touch and it does light. So let me show you. We touch and off, on and off. Okay, good. So that works well. And now this system is functioning as normal. This Land Cruiser 100 had an ABS warning and a brake warning because some stupid ass mechanic decided to put the wrong part number cluster in here. Respect your part numbers. When you take a part number out, put the same part number inside. People who work in factories are not schizophrenic. They just don't give part numbers for no reason. There's a reason why part numbers exist. And now you see why. This wrong part number was put in here. Then they attempted to do some shenanigans inside. Didn't work. They attempted to disable the bulbs. Still didn't work. Then they finally taped over the bulbs and put manual bulbs in there, which the owner had taken out before the car came to me. It is what it is. Be careful who you take your vehicle to. And if you take your vehicle to K Mechanics, you know it'll be done right. All right, guys, until next time. So how about this Gemini analysis? It never ceases to amaze me how confidently AI spits out such nonsense. And it only looks very nice to people who have no idea of what they are reading. If you don't know your craft, or if you don't know the topic at hand, AI sounds convincingly good. But I can't begin to tell you how bad this is. They cut the wires in the cluster plug to kill the height control lights. Did Gemini look at the plug? How did Gemini know this? How did Gemini analyze this to come up with such a conclusion? When they did that, they accidentally cut a shared master ground or ignition power track that the ABS system and cluster gauges rely on. Did Gemini look at the wiring diagram? There's no shared master ground or ignition power track that the ABS system and cluster gauges rely on. That's just made up. Because that ground circuit was severed, the cluster began backfeeding electricity through the radio's accessory line. The accessory line of the radio doesn't even pass anywhere near the cluster. There's no way the cluster and the accessory line can come anywhere close to being together even in the same harness. And then to hide the fact that the ABS light came on as a side effect of this bad wiring, they cut the ABS wire and rigged up a reverse logic cheat bulb. So how did Gemini know this? Did Gemini look up the address of the resident mechanic who did this? How is this even something that somebody can take seriously? I tell you, you people who use AI, you need to understand that this stuff is really glorified nonsense. If you do not know what you are doing, then this stuff sounds very, very good. But now that we've seen the diagnosis, you can begin to see what this thing really is. And I won't say it. I'll let our resident 2-year-old actually say it for you.
A bullshit? A bullshit? A bullshit. A bullshit.